Okay, this is the apparatus we use to make hydrogen. There's the gas generating bottle. This one's got zinc in it. We're going to use a reaction similar to what Boyle used. He used copper, he used iron, I guess, and sulfuric acid solution. That's when he first discovered hydrogen. We're going to use zinc. It works a little faster than iron does. We're going to collect it in these bottles. And over here, notice that the bottles, the long stem comes out of the bottle and the short stem goes in. Because hydrogen's lighter than air. We're not going to fill it up. We're going to fill these bottles down. They'll get to the top and fill down and go over to the next one. And then we got that beaker over there to tell if we have any leaks. And Angelique has already measured out the sulfuric acid solution. We're using 6 molar sulfuric acid. She's measured out 35 milliliters, and she's going to put it into the gas generating flask now. Now, according to the instructions, I should have put a little bit of copper sulfate in there to activate the zinc, but we're going to do it a little differently. We're going to add the copper sulfate after we add the acid to show it that does speed it up. It activates the surface of the zinc. And that's granular zinc. And you can see there's bubbles there. Can you see it? And over there you can see that there are bubbles being produced, so there's no leak, but it's not very fast. And so I'm going to add a little bit of copper sulfate solution. Can you see it? It's a nice pretty blue solution. Why don't you just open that up if you can? Maybe it's too tough. And just add just a few milliliters, and I'll videotape how it looks after you add it. Let me undo this for a second. Oh, it's going in there. You see, it's starting to go faster. Pour a little bit more in there and see if we can get it into the bottom. Yeah, there we go. Now you can see it's definitely going faster now. See that? It does speed it up. Look at this. Look at that baby go. Any evidence of gas being produced? Uh-oh. Any evidence of a fast reaction? Look, it's hot too. I guess we put too much copper sulfate in, you think? We'll have to get another one for number 4, won't we? That's funny. Did you like that one? I liked it too. We can end it, right, for this moment. Hydrogen now is much less dense than air, so if we take the stoppers out, it's going to come right out. So the only way we can do it is to disconnect it and turn it upside down before we take the stopper out. And I have the glass plate here. This is the way we do it. Okay? And we'll leave it on that stopper. Part 2, we're supposed to take this, put it right side up. I'm supposed to light a wooden splint. Let me get another wooden splint here and light it over the top after I take the stopper out and see if you see any activity. I think this is what we're supposed to do, right? Let me get this over here. Did you see anything? Did you see it?
Yes.
Now that happened, that's called an explosion, isn't it? So the hydrogen came out and mixed in with air, and so hydrogen is very flammable, and when it mixed in with air, it made an explosive mixture. Okay? That's kind of cute. Now the next one, you ready for the next one? I think what we're supposed to do is show the hydrogen less dense than air. And I will take this upside down again. Right? Is that correct? So this is hydrogen. I'm going to turn this up right side up. Now, to keep the hydrogen in there, then we're going to put a bottle of air over it. And we know that air doesn't burn, right? So I'm going to pull the stopper out, the glass plate out, and then if hydrogen goes up, it should mix in there, right? So we do that. Okay, now it should be going up. If it really goes up, it should make an explosive mixture, shouldn't it? So let me get 2 glass plates. I can take these apart, aren't they? And I'll take this off. And that should have a mixture of hydrogen and oxygen in it. So if there is a mixture there, it should be explosive. Let's see. Because it's a mixture of hydrogen and air, which is a mixture of hydrogen and oxygen. Let's see, I don't know. Yes, it is explosive. We try the other one. They're a little different, right? They weren't completely mixed yet. This one's a little lean, that's a little thick. Okay, now, if that's pure hydrogen in there, we're going to try another experiment, because hydrogen does not support combustion. And the only place that can burn is if there's oxygen present. So there should be oxygen at the mouth of the bottle, but there's no oxygen inside, so the hydrogen itself can't burn. And this, in order for this to burn, it has to have oxygen, doesn't it? And there's no oxygen in there. So I think I can put this fire out by sticking it in there. Let's see. See the fire went out on the end of the stick? And look, it lit the stick in the middle because it was burning at the mouth of the bottle. Isn't that cute? Okay, so this is hydrogen here, and I'm going to put it over the oxygen here. So that's hydrogen on top and oxygen down below, right? And now this is the light gas and that's the heavy gas. So I take the stoppers out, they shouldn't mix, except in a gas the molecules are moving. They're moving quite fast. So we're going to see if the diffusion of the gases due to their movement will allow them to mix. How can we tell? Well, if they don't mix, we'll have hydrogen above and oxygen down below, and we know what they behave like, right? So we'll let it mix for 2 minutes. I'm going to take it out of here, leave the hydrogen on top of the oxygen. They should be mixing, and so we'll let it go for 2 minutes to see if that's enough time for them to mix. And then I'll put the glass plates in there and we'll test them. We'll test the lower one and the upper one. Okay, now that's been about 1 minute 45 seconds. Now I'm going to put the glass plates back in, and I'm going to separate these and keep them face down. Bottom down. Whoops. For both. Now this one was the hydrogen and this was the oxygen, right? Oxygen in there, so it only burn at the mouth of the bottle, right? Isn't that true? I think that's true. And if there is oxygen in there, then it might be an explosive mixture, right? So it's either going to just burn or it's going to explode. I'm not sure. Let's see. You ready? Yeah, then mixed. Any evidence that oxygen got in there? Yes. Now let's do the other one. See if any hydrogen got down there. Did you hear the difference? Did you hear the difference? You know why that was different? This had too much oxygen, so that was too lean. Too lean of the combustible gas. And it went poof. But it still exploded, and this one was actually too rich because they hadn't completely mixed. In 2 minutes time, there was not enough time for them to mix. Now if we'd done it the other way and turned them over so they could mix by using gravity, then the explosion would be very loud and you would have been scared. Okay, that's the end of the experiment, I believe.